Welcome to Summarize Science. Today, we are looking at a fascinating new way to make robots move naturally. Have you ever noticed how AI-generated characters often seem to float or slide around unnaturally? This happens because most AI models are trained on visuals, not on the actual laws of physics. When researchers try to put these motions onto a real robot, the results can be quite messy. To fix this, a new framework called PhysMoDPO has been introduced. On page 2, you can see the difference it makes for a humanoid robot called the Unitree G1. Without this training, a robot might lose its balance or move in ways that are impossible in the real world. The researchers integrated a whole-body controller directly into the training pipeline to measure physical realism. This system uses something called direct preference optimization to bridge the gap between imagination and reality. Instead of just trying to look right, the AI learns to prefer motions that actually work in a physical environment. The overview on page 5 shows how the process works in 3 main stages. First, the model generates multiple potential motions for a single text command. Then, a physics simulator tests these motions to see which ones are the most stable and realistic. Finally, the generator is updated to focus on the successful movements. The AI is rewarded based on how well the robot tracked the motion without falling or sliding. It also gets points for making sure the robot still follows the original text instructions, like kicking with a specific leg. This creates a feedback loop where the AI gets better at predicting what is physically possible. As shown on page 10, the results are much more stable than previous methods. Characters can now step forward, do a handstand, or run and stop without glitching out. The red boxes in the images highlight where older methods failed to maintain balance. One of the most impressive parts of this work is how well it transfers to real-world robots. Page 13 displays a real Unitree G1 robot performing complex sequences like walking in a circle or bending at the knees. These aren't just animations, they're actual physical movements executed by a real machine in a lab setting. Even more amazing is that this was done in a zero-shot way, meaning the AI didn't need extra training for this specific robot body. A user study on page 14 confirms that people find these motions much more realistic and stable than the alternatives. In summary, PhysMoDPO solves the skating feet and balance issues that have plagued AI motion for years. By using physics as a guide, the researchers have found a way to make AI-generated movements truly executable. This means that in the future, we could give a simple voice command to a home robot and it would know exactly how to move safely. It could lead to a world where robots move with the same grace and efficiency as humans. This research marks a major step toward making embodied AI a part of our everyday lives. Thank you for watching this breakdown on Summarize Science.